A firm uses a turning center, a milling center, and a grinding machine to produce two parts. The table shown below provides the machining time required for each part and the maximum machining time available on each machine. The profit per unit on part 1 and 2 are 40 and 100 respectively. And these are the denominations. You can write it as pounds, you can write it as dollars, or you can write it as rupees. Anything you want. You have to calculate the maximum profit per week of the firm in this particular denomination. Now, this type of numericals can be solved by simplex method, in which the constants are written in equation format. And if you have studied engineering mathematics, this is the very first unit there. Or even in our high schools in certain countries, this particular method has been covered. So first of all, we are going to convert all the constants into equation format. So for the turning center, the constants can be written as 12x plus 6y less than or equals to 6000. For the milling center, 4x plus 10y less than or equal to 4000. And for the grinding machine, 2x plus 3y is less than or equal to 1800, in which x and y are obviously greater than or equals to 0. Now, by drawing the graph of all these three or basically four equations, we find the point of confluence is at point B here. As you can see, it's 375 and 250. This is done graphically. Now let's solve these equations to get the same point. See, these equations can be rewritten as 12x plus 6y is equal to 6000, 4x plus 10y is equal to 4000, and 12x plus 30y is equal to 12,000. How come we are just dividing the third equation with 6 so that it can become equivalent to the first equation itself, and we can cancel them out to find the values of x and y. And hence we have the value of x as 375 and the value of y is 250. And hence we can deduce that this is the optimum solution. That is, the point 375 250 is the optimum solution. It's the intersection basically of the first and the second constant. And hence we can calculate the profit as 40 into 375 plus 100 into 250. Why? Because profit per unit on part 1 and 2 were 40 and 100 respectively. Next question. Two models P and Q of a product earns profit of 180 per piece. The production time for P and Q are 5 hours and 3 hours. While the production time available, the total production time available is 150 hours. You have to calculate the total batch size of 40 to maximize profit and the number of unit of P to be produced. To solve this numerical, let us assume x and y be the number of units of production of P and Q products respectively. And hence, again writing the constants in equation format here, we have x plus y is equal to 40, that is the total batch size, and 5x, that is 5 hours production time for P, plus 3y, that is 3 hours production time for Q, is equal to total production time of 150. Solving this, we get x is equal to 15. That means 15 number of units of P is to be produced.